All right, so today we have Unit 1, Lesson 6. This is kind of like the halfway point of the first unit. So really these lesson notes, there really isn't anything new. This is just kind of a summary of what we've learned so far in this unit. We, of course, the big thing is the difference between a geometric and a arithmetic sequences, and we've learned about these different ways to represent a sequence. You could have a list of terms. You could have a table. You could have a graph. Remember, in a geometric sequence, the graph is usually exponential, and in an arithmetic sequence, the graph is usually linear. And then we also have the recursive definition that we talked about yesterday. As far as the lesson examples go, our lesson examples are just more practice with the recursive definition. So let's go to the examples here. All right. So for each of the following sequences, okay, determine if it's geometric, arithmetic, or neither, and write a recursive definition. Okay, so let's look at number 1. So number 1, we go from 3 to 7 to 11 to 15. That looks like an arithmetic sequence to me. Why is it an arithmetic sequence? Because the common difference is 4. We're going up by 4. 3 plus 4 is 7, plus 4 is 11. So if we look back at our lesson notes from yesterday, remember this right here is our how we write the recursive form or the recursive definition. So our starting term, f of 0, is going to be 3, okay, since that's our starting term, okay? And then our second part, we are going to do this one because our pattern is to add. So f of n is going to be equal to f of n minus 1 plus our common difference is 4. Okay. So that's number 1. Let's look at number 2. Okay, we go from 10,000 to 2,500 to 625. Clearly, it's not arithmetic. Let's check and see if it could be geometric. Okay. So I'm checking on my calculator right now, and it looks like we're dividing by 4. Okay, 10,000 divided by 4, according to my calculator, is 2,500. 2,500 divided by 4 is 625, so on and so forth. So this is a geometric sequence, and our common ratio is not going to be 4. Our common ratio is 1/4. Okay, so our starting term f of 0 is going to be 10,000. Okay, and then f of n is going to be f of n minus 1 times, since it's geometric, times 1/4. Okay, and that is our answer for number 2. Okay, number 3. Okay, we go from 1 to 4 to 16 to 64. Clearly not arithmetic. Let's check geometric. It looks like we're multiplying by 4. So it's a geometric sequence with a common ratio of 4, because 1 times 4 is 4, 4 times 4 is 16, so on and so forth. So f of 0 is going to be equal to 1. And then f of n is going to be equal to f of n minus 1 times 4, since that's our common ratio. Okay, and last example. Number 4, we go from 10 to 8 to 6 to 4. That is clearly an arithmetic sequence. Okay, that is clearly an arithmetic sequence. Our common difference is going to be -2 because we are going down. We're subtracting 2 every time. So our recursive form, our f of 0, our starting term is going to be 10. And f of n will be equal to f of n minus 1 minus 2.